Introduction. Can anyone tell what similar triangles are? Sir, similar triangles are triangles whose corresponding angles are the same, but whose corresponding sides may be of different lengths. Absolutely correct. Look at this triangle now. Which triangle is this? Right triangle. Correct. Now if one side of this triangle is 10 centimeter, second side is 15 centimeter, then can you tell the length of the third side? Yes, we can find the length of the third side using Pythagoras theorem. So what is Pythagoras theorem? Today we will learn about Pythagoras theorem. Come, let's start. Objectives. At the end of this lesson, you will be able to calculate areas of similar triangles, state and prove Pythagoras theorem, and solve questions based on Pythagoras theorem. Areas of similar triangles. Theorem. The ratio of the areas of two similar triangles is equal to the square of the ratio of their corresponding sides. Let us prove this theorem. Two triangles PQR and XYZ are given such that triangle PQR is similar to triangle XYZ. To prove, area of triangle PQR upon area of triangle XYZ is equal to PQ upon XY whole square equals QR upon YZ whole square, which is equal to RP upon ZX whole square. Construction. For finding the areas of the two triangles, draw PM is perpendicular to QR and XN is perpendicular to YZ. Prove. Area of triangle PQR is equal to 1 by 2 QR into PM and area of triangle XYZ is equal to 1 by 2 YZ into XN. Area of triangle is equal to 1 by 2 into base into height. Therefore, area of triangle PQR upon area of triangle XYZ equals QR upon YZ into PM upon XN. Mark it as 1. In triangle PQM and XYN, angle Q is equal to angle Y. Triangle PQR is similar to triangle XYZ. Angle PMQ equals angle X and Y. Each angle is equal to 90 degrees. Therefore, triangle PQM is similar to triangle XYN by AA similarity criterion. Thus, PQ upon XY equals PM upon XN. Also, since triangle PQR is similar to triangle XYZ, PQ upon XY equals QR upon YZ, which is equal to RP upon ZX. Mark it as 3. From equation first, area of triangle PQR upon area of triangle XYZ equals PQ upon XY whole square by using equation 2 and 3. Now by using equation 3 we get area of triangle PQR upon area of triangle XYZ equals PQ upon XY whole square, which is equal to QR upon YZ whole square, which is equal to RP upon ZX whole square. Hence, the ratio of the areas of two similar triangles is equal to the square of the ratio of their corresponding sides. Example. Triangle ABC is similar to triangle DEF and their areas be respectively 64 cm square and 121 cm square. If EF is 15.4 cm, find BC. Solution. It is given that triangle ABC is similar to triangle DEF. Therefore, area of triangle ABC upon area of triangle DEF equals AB upon DE whole square equals BC upon EF whole square equals AC upon DF whole square. Also, given that EF equals 15.4 centimeter, area of triangle ABC is 64 centimeters square and area of triangle DEF is 121 centimeters square. Therefore, area of triangle ABC upon area of triangle DEF is equal to BC upon EF whole square. Now, by substituting and calculating the values, we get BC as 11.2 centimeter. Example: in the given figure, ABC and DBC are two triangles on the same base BC. If AD intersects BC at O, show that area of triangle ABC upon area of triangle DBC equals AO upon DO. Solution: let us draw two perpendiculars AP and DM on line BC. We know that area of a triangle is equal to 1 by 2 into base into height. Therefore, area of triangle ABC upon area of triangle DBC is equal to AP upon DM. In triangle APO and triangle DMO, angle APO equals angle DMO, each 90 degrees. Angle AOP equals angle DOM, vertically opposite angles. Therefore, triangle APO is similar to triangle DMO by AA similarity criterion. Therefore, AP upon DM equals AO upon DO, which implies area of triangle ABC upon area of triangle DBC equals AO upon DO. Example: prove that the ratio of the areas of two similar triangles is equal to the square of the ratio of their corresponding medians. Solution: let us assume two similar triangles as triangle ABC is similar to triangle PQR. Let AD and PS be the medians of these triangles. Because triangle ABC is similar to triangle PQR, therefore AB upon PQ equals BC upon QR, which is equal to AC upon PR. Mark it as 1. Angle A equals angle P, angle B equals angle Q, angle C equals angle R. Mark it as 2. Since AD and PS are medians, therefore BD is equal to DC, which equals BC upon 2, and QS is equal to SR, which equals QR upon 2. Equation 1 becomes AB upon PQ as BD upon QS, which is equal to AC upon PR, which is equation 3. In triangle ABD and triangle PQS, by using equation 2, angle B is equal to angle Q, and by using equation 3, AB upon PQ equals BD upon QS. Therefore, triangle ABD is similar to triangle PQS, SAS similarity criterion. Therefore, it can be said that AB upon PQ equals BD upon QS equals AD upon PS. Mark it as 4. Area of triangle ABC upon area of triangle PQR equals AB upon PQ whole square equals BC upon QR whole square equals AC upon PR whole square. From equations 1 and 4, we may find that AB upon PQ equals BC upon QR equals AC upon PR, which is equal to AD upon PS, and hence AR triangle ABC upon AR triangle PQR equals AD upon PS whole square. Pythagoras theorem. If a perpendicular is drawn from the vertex of the right angle of a right triangle to the hypotenuse, then triangles on both sides of the perpendicular are similar to the whole triangle and to each other. This theorem is applied to prove the Pythagoras theorem. Pythagoras theorem was earlier given by an ancient Indian mathematician, Baudian, about 800 BC in the following form. The diagonal of a rectangle produces by itself the same area as produced by its both sides, that is, length and breadth. This theorem is sometimes also referred to as the Bothian theorem. In a right triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. Let us prove this theorem. Prove. ABC is a right-angled triangle. Angle B is equal to 90 degrees. To prove, AC square equals AB square plus BC square. Construction. Draw BD perpendicular to AC. Prove. In triangles ADB and ABC, angle A is equal to angle A, common. Angle ADB is equal to angle ABC, each 90 degrees. Therefore, by AA corollary, triangle ADB is similar to triangle ABC, which implies that AD upon AB equals AB upon AC, because in similar triangles, corresponding sides are proportional. Or we can write it as AB square equals AD into AC, mark it as 1. Similarly, BC square equals DC into AC, mark it as 2. By adding 1 and 2 we get AB square plus BC square equals AD into AC plus DC into AC, which equals AC into AD plus DC, AC into AC, AC square. Therefore, AB square plus BC square equals AC square. Hence proved. Converse of Pythagoras theorem. In a triangle, if a square of one side is equal to the sum of the squares of the other two sides, then the angle opposite the first side is a right angle. Example of Pythagoras theorem. ABC is an isosceles triangle right-angled at C. Prove that AB square is equal to 2AC square. Solution. Given that triangle ABC is an isosceles triangle, therefore AC is equal to CB. Applying Pythagoras theorem in triangle ABC, that is, right-angled at point C, we obtain AC square plus CB square equals AB square, which implies 2AC square equals AB square. In the given figure, ABD is a triangle right-angled at A and AC is perpendicular on BD. Show that 1. AB square is equal to BC into BD. 2. AC square is equal to BC into DC. 3. AD square is equal to BD into CD. Solution. 1. In triangle ADB and CAB, angle DAB equals angle ACB, each of 90 degrees. Angle ABD equals angle CBA, common angle. Therefore, triangle ADB is similar to triangle CAB by AA similarity criterion, which implies AB square as CB into BD. 2. Let angle CAB equals X. In triangle CBA, angle CBA is 180 minus 90 degrees minus X, which is equal to 90 degrees minus X. Similarly, angle CAD is 90 degrees minus angle CAB, which is 90 degrees minus X. Angle CDA is 180 degrees minus 90 degrees minus 90 degrees minus X, which is equal to X. In triangle CBA and triangle CAD, angle CBA is equal to angle CAD, angle CAB is equal to angle CDA, angle ACB is equal to angle DCA, each is 90 degrees. Therefore, triangle CBA is similar to triangle CAD by AAA rule, which implies AC upon DC equals BC upon AC, which implies AC square equals DC into BC. 3. In triangle DCA and triangle DAB, angle DCA equals angle DAB, each in 90 degrees. Angle CDA equals angle ADB, common angle. Therefore, triangle DCA is similar to triangle DAB by AA similarity criterion. DC upon DA equals DA upon DB, which implies AD square equals BD into CD. Example. Prove that the sum of the squares of the sides of a rhombus is equal to the sum of the squares of its diagonals. Solution. In triangle AOB, triangle BOC, triangle COD, triangle AOD, applying Pythagoras theorem, we obtain these values. By adding all these equations, we obtain AB square plus BC square plus CD square plus AD square equals AC square plus BD square. Example of Pythagoras theorem. In the following figure, O is a point in the interior of a triangle ABC. OD is perpendicular to BC, OE is perpendicular to AC, and OF is perpendicular to AB. Show that 1. OA square plus OB square plus OC square minus OD square minus OE square minus OF square equals AF square plus BD square plus CE square. 2. AF square plus BD square plus CE square equals AE square plus CD square plus BF square. Solution. Join OA, OB and OC. 1. Applying Pythagoras theorem in triangle AOF, we obtain OA square equals OF square plus AF square. Similarly, in triangle BOD, OB square equals OD square plus BD square. Similarly, in triangle COE, OC square equals OE square plus EC square. Now, by adding these equations, we get 2. From the above result, AF square plus BD square plus EC square equals OA square minus OE square plus OC square minus OD square plus OB square minus OF square. Therefore, AF square plus BD square plus CE square is equal to AE square plus CD square plus BF square. Did you know? The Pythagorean theorem is one of the earliest known theorems to ancient civilizations. It was named after Pythagoras, a Greek mathematician and philosopher. The Chao Pei, an ancient Chinese text, also gives us evidence that the Chinese knew about the Pythagorean theorem many years before Pythagoras or one of his colleagues in Pythagorean society discovered and proved it. Pythagoras lived in the 6th or 5th century BC. He founded the Pythagorean school in Crotona. This school was an academy for the study of mathematics, philosophy, and natural science. The Pythagorean school was more than a school. It was a closely knit brotherhood with secret rites and observances. Summary. Let us summarize what we have learned. The ratio of the areas of two similar triangles is equal to the square of the ratio of their corresponding sides. If a perpendicular is drawn from the vertex of the right angle of a right triangle to the hypotenuse, then the triangles on both sides to the perpendicular are similar to the whole triangle and also to each other. In a right triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides, Pythagoras theorem. If in a triangle, the square of one side is equal to the sum of the squares of the other two sides, then the angle opposite the first side is a right angle.